Yes, sir.
Okay, okay. So this is the first question I have taken. So first we will check whether this is working in continuous or discontinuous. Okay. So here a buck boost converter is given and L value is given as 0.6 millihenry and R is 5 ohm, operating at 10 kilohertz frequency, and duty of the switch is 0.6. And here the output voltage is constant at 75 volt. 75 volt, and input is 50 volt. So for boundary condition, already I have explained. Boundary means it will be like for on time, it will go like this, charging for D1 and discharging for 1 minus D. So this is for D and this is for 1 minus D. So if this condition will happen, in that case we can say that it is working as a boundary condition. Okay, this is the inductor current. And another case will be there where it will be higher than this one, like it will be some maximum and some minimum value. So this is the bound, like it will be higher than. So here it is continuous conduction. Inductor current will have one minimum value and one maximum value, and this will be the average of the inductor current, IL average. So how we can say that it is continuous or discontinuous? If IL average is greater than delta IL by 2. What is delta IL? Delta IL is peak to peak inductor current. This. So if we'll see here, this is delta IL. So for this condition, we can say that IL average is equal to delta IL by 2. Okay. So this is the just at boundary of continuous and discontinuous conduction. Here this is IL average, it is middle of this one. So we can say that for this condition, IL average is delta IL by 2. So when this IL average is greater than delta IL by 2, that will be the condition for continuous conduction. Okay. So from this equation only we can derive. So for buck boost converter, what will be the IL average? It will be I naught divided by 1 minus D. And delta IL will be dVs by L. This will be due to dVs by 2 LF. Should I derive this one, or all of you know this? How delta IL is equal to dVs by LF. Should I derive this one?
What's derived, sir?
Okay. See. So this is the duty. This is the duty. Okay. So we can see from here, this is inductor voltage VL. So, and this is delta IL. So for this one, I'm going to apply the slope equation. So what is VL? VL is equal to L di by dt. So you can write as di by dt, it should be equal to VL upon L. So during on condition, when this switch will be on for this time and off for 1 minus d time. Okay. So when this switch will be on, what will be the value of VL? VL will be equal to VS, source voltage. Okay. So this equation I can write as di by dt. So di by dt is the slope of this line. So what will be the slope of this line? The slope of this line will be this y2 minus y1, y2 minus y1. It will be delta IL. So delta IL divided by this x2 minus x1. This is x2 and this is x1. So this will be dts. dts. Total time period is ts, and this on time period is dts, and off time period is 1 minus dts. Okay. So what will be the slope? Slope will be delta IL by dts. So this we can equal to VL. VL how much? VS. Okay. So dVs, 1 second. Vs upon L. Here it will be L. VL is Vs, Vs upon L. So delta IL from this, here we can see that delta IL is equal to dVs Ts divided by L. So that will be equal to Ts will be put in denominator. So we can write that delta IL is equal to dVs divided by LF. Is it clear now? The ripple current, this expression will be dVs divided by LF, where D is the duty, Vs is the source voltage, L is the inductor, and F is the switching frequency. Is it clear now?
Yes, sir.
Okay. So see, so what is the continuous conduction condition? That is IL average should be greater than delta IL by 2. So I have directly written here I naught divided by 1 minus D. If we'll apply here ampere second balance, so we'll find the relation that what will be the average inductor current. Okay, IL average, it will be equal to I naught divided by 1 minus D. So IL average should be greater than delta IL by 2. It means that I naught divided by 1 minus D should be greater than dVs by 2LF. Okay. So further this equation we can write as I naught divided by 1 minus D. It should be greater than dVs upon 2LF. Okay. So one second. One second. So here what we can write I naught is equal to V naught by R. Okay. What is V naught? What buck boost converter? V naught is equal to D upon 1 minus D into Vs. So finally here we can write as V naught into D divided by R into 1 minus D square. This should be greater than, here it will be Vs, should be greater than dVs divided by 2LF. Is it clear? If I naught is V naught by R and V naught is equal to D by 1 minus dVs. So this I have written here. So it will be dVs divided by R into 1 minus D square. So finally we can write as this, I am taking it this side. So 2LF divided by R, this should be greater than 1 minus D square. Okay. Further we can write as this, in another way we can write as 2L divided by RT TS should be greater than 1 minus D square. So if this condition will satisfy, then we can say that the converter is working in the continuous conduction. So this you have to remember. This condition you have to remember. This equation is clear to all?
Yes, sir.
Okay. So for like this value, we are saying it as a constant. Let's say constant. Some k should be greater than k critical. Okay. This constant will be same for buck boost and buck boost. All three, if you do the derivation, this constant will be same. So if k should be k is greater than k critical, we can say that the converter is working in continuous conduction. So this k critical for buck boost is 1 minus D square. Okay. Similarly, we can derive for other converters also. So now coming to the question, see here, what is the values? L is 0.6 milli, R is equal to 5. L is equal to 0.6 milli, R is equal to 5 ohm. And what is the TS? So frequency is 10 kilohertz. F is 10 kilohertz. Okay. And duty how much? Duty is 0.6. Okay. So 1 minus 0.6 square how much? Can anyone calculate and verify these two values, whether it is satisfying or not? So 2 LF by R, 2 into
0.16, sir.
0.6 milli into frequency how much? 10K divided by R, 5 is greater than 1 minus 0.6 square. This condition is satisfying or not? Can you calculate? If this is satisfying, means we can say that converter is working in continuous conduction. 2 into
2.4 greater than
2.4 greater than how much?
1.6. 1.6.
This is 1 minus 0.6 square. So 0.4 square. No?
0.16. 0.1.
This is 0.16. So it means we can say that converter is working in continuous conduction. Okay.
0.16, sir.
Okay, 0.16. So if this first you have to check this condition. If this is satisfying, means we can say that converter is working in. If this will not satisfy, then we can solve for discontinuous. Okay. So now coming to the second part of this question. What is the second part? We have to calculate the switch peak current. Okay. What is the peak current through this switch? So how we can calculate? This switch current waveform will be like this. Okay, first will flow through this inductor. When switch will be off, this part will flow through this diode. So this peak we have to calculate. So how we can calculate? First we should know the average inductor current, IL average, and delta
I
I.
naught plus I naught plus delta IL by 2, sir.
No,
IE.
not I naught, IL plus delta IL by 2. This will be the peak value of the source current. See,
Yes, sir. Yes,
this
sir.
inductor current is following through this one. So this is the first part of the inductor current. So on charging time, the peak value of the inductor current and plus average inductor current. This will only flow through this source. So peak value of the inductor current will be the peak value of the source current. Is it clear? So we can calculate one by one. So what will be the value of delta IL? Can anyone tell? dVs by LF. D into Vs by LF. Duty is 0.6. 0.6 into 50 divided by 0.6 into 10k. How much? D into Vs. D is 0.6. Vs how much? Vs 50 divided by 0.
5.
It is coming as 5. Okay.
Mm.
So delta IL by 2 will be how much? 2.5.
Yes, sir.
Delta IL by 2 will be 2.5. And what is the output current here? R value is 5 ohm and output voltage is 75. Is that?
15 amps. 1.5.
So I naught is 15
15.
ampere. So inductor current will be I naught divided by 1 minus D.
Sir,
1
inductor
minus.
current 37.5.
So it will be 37.5. So now we can draw the inductor current waveform. This minimum, like average will be 37.5. So minus 2.5, it will be 35 here. It will start from 35 and it will go up to 40. 37.5 plus 2.5.
40 amps, sir. Which peak current is 40 amps?
So this will be the final answer. ISW peak will be 40 ampere. Okay. And if other question also it can be asked like what will be the RMS value of the switch current. So that already I have told you the formula. This is minimum 35. Okay. Maximum is 40. So that formula you can apply. This is duty. So how we can calculate? U is equal to 1 by 3 35 square plus 40 square plus 35 into 40. This will be the value of U and ISRMS will be equal to duty into U. This will be the RMS value of the source current. Source current or we can say switch current also. Both are same. Okay. So should I move to the next question or anyone have doubt they can ask?
Critical inductance value, sir. That one.
For this question, critical inductance you want to say?
Yes, sir.
See, so from this equation only we can derive. This is the equation. Okay, so this is the boundary condition. Boundary condition means delta IL should IL average should be equal to delta IL by 2. Okay, that also I will derive. 1 second. For critical condition, this is the boundary condition. Okay. On time dTs and off time 1 minus d into Ts. This is IL average. So for critical condition, what will be the value of inductor current? IL average should be equal to delta IL by 2. This is the boundary condition. Okay. So this will be, how we can say, it will be I naught by 1 minus D. And here it will be dVs divided by 2LF. Okay. So further we can simplify this as I naught is equal to V naught by R. So V naught we can write as V naught into d divided by r into 1 minus d square. This is equal to dvs by 2lf. Same equation. So dvs will be cancelled. Okay. So what will be the value of r? R critical will be 2lf divided by 1 minus d square. In other way, we can say that L critical will be equal to 1 minus d square into r divided by 2f. Is it clear? Same, this condition only. This is the boundary condition. If you will apply this condition, we can calculate the critical resistance or critical inductance. So if inductance will be less than this value, in that case we can say that it is discontinuous. At this value it will be continuous. If it will be less than this value, it will be discontinuous. And resistance, we can say that this is the minimum resistance. If resistance will be more than this, then it will be discontinuous. Is it clear?
Clear, sir.
Okay, okay. So just you have to think in terms of inductor current, not the output current. What people do, that for buck converter, first they will analyze. So in buck converter, inductor current and load current both are same. But in other two converters, inductor current are different than load current. So for boundary condition, always we have to consider the inductor current, and we have to calculate like this, like IL average is equal to delta IL by 2. This condition we have to satisfy, then we can derive the critical value equations. So can I move to the next question?
Yes, sir.
Okay.
Yes, sir.
Okay, so this is the next question. Here a boost converter is given, a buck boost converter is given, and we have to calculate what will be the duty of this switch. Okay. So first we will check whether this is working in continuous or discontinuous mode. Okay. So how we can check? Same thing. Let's say option also will be given. Let's say normal. What will be the normal if it is working in continuous conduction mode? Can anyone calculate the duty? D divided by 1 minus D equal to V naught by Vs. Okay, what will be the duty from this equation? We can write as 1 by D minus 1 is equal to Vs by V naught. So it will be Vs is 15 by V naught. So 1.5. So 1 by D will be 2.5 and D will be 0.4. So this is the normal duty. If this converter will work in continuous conduction mode, so then this duty should come. Okay. So we will first verify with respect to continuous conduction. So 1 minus D square. What formula we have derived? This is critical, and 2L by 12F by R. This should be greater than 1 minus D square. Then only we will say that this converter is working in continuous conduction. Okay. So can anyone calculate this value? 2LF divided by R. 2 into L, how much? L value is not given here. 0.05 milli. 0.05 milli into 20K divided by R value will be how much? Can anyone tell from this information? So this voltage is 10 and power is 10. So what will the value of R?
10 ohm, sir.
10 ohm. So divided by 10. So what will be this value? 2 into 0.05 milli into 20K. How much it will be? 2 into 0.05 into 20 divided by 10. It's coming at 0.2. This value I am getting as 0.2. So is it satisfying? 0.2 is greater than 1 minus D square. Is it satisfying? So 1 minus D square how much? 0.36. This is not satisfying. 0.2 is less than 0.36. So from this information we can say that the converter is working in discontinuous conduction mode. Is it clear to all? This value
Yes,
is
sir.
this is 0.36 and this is 0.2. So this condition is not satisfying. So now we will analyze this converter with respect to the discontinuous conduction. Okay. Then we will calculate the duty. What will be the actual duty of this switch? Actual duty is not 0.4. See, if objective question will be given and in one of the option will be 0.4 and directly we will click that 0.4, that will be the wrong answer. So first we have to go through this. If nothing will be given in the question and 2 marks question will be there, then we have to check first whether this converter is working in continuous or discontinuous. Okay. So how we can solve this question? Now I'm moving next part. So 1 second. So here current we can calculate. What will be the current here? Average current 1 ampere. Okay. So discontinuous waveform will be like this. IL waveform I am going to draw. So on time and this is off time. This is total time period TS. This is, let's say, duty 1 D1 TS, and this duration is D1 TS and this duration is D2 TS. And for D3 TS current is 0. Okay. So if we'll see here, this current will present for D2 TS time only, so we can draw this current as this one. Same current will go in this average current of this average value of this current will be the average value of the load current. So we can calculate the average value of the load current from this waveform. This is D2 TS, okay, and this is TS. And if we'll calculate average of this current, so this will be I not average. If we'll calculate average of this waveform, then it will be average of the output current. Is it clear? Is it clear to all? The average value of this current will be the average value of the output current. See,
Sir, we find on period and off period, sir, separately.
both we can find D1 and D2, both we can calculate. So it is asking duty means this is the duty D1. See, this is a charging time and this is the discharging time. Okay, here, but total time period is this one. Okay, total time period is coming up to, again this current will start like this and will, so it is conducting up to here only. For D3 TS time the current will be 0, inductor current will be 0. Okay, if it will come up to here, if it will come up to here, then we can say that this is boundary condition. But if it discharging before this time period, so this is the discontinuous conduction mode. So I'm saying that if we are calculating the average value of this waveform will present in D2 time like this inductor current. So this is inductor. So it is charging and discharging. So charging means this switch will be on, discharging means it will flow in this direction. So that second part current average value will be the average of the output current. Okay. Is it clear to all?
Okay, sir, clear, sir.
So that information already we have. This average value load current how much? 1 ampere. So we'll equate this to 1 ampere. So 1 ampere should be equal to average of this waveform. So what will be the average? 1 by T into area. This concept we can apply here. 1 by T into area. So what will be the peak value here? Same concept we can apply like delta I, BL is equal to L di by dt. Okay. So what is the value of VL during this condition? So this is delta IL. Off condition, like when the switch will be off, so this is the VL. VL will be equal to, see here it is minus and here it is plus. In buck boost converter it will be like this, here it is plus and here it is minus. So what will be the value of VL? VL will be minus V naught. Okay. So we can write here as minus V naught should divided by L should be equal to delta IL. So delta IL, this Y2 minus Y1. So Y2 minus Y1 we can write as minus delta IL divided by how much? D2 TS. So what will the value of delta IL? Delta IL is equal to V naught d2 Ts divided by L. So we can have calculated this value, y value. Okay, is it clear? Delta IL calculation. Is it clear to all?
Yes, sir.
So here same thing we can apply 1 by T into what will be the area 1 by 2 into this base d2 Ts into this delta IL. So delta IL V naught d2 Ts by L. So from this is 1, Ts will cancel. So it will be 1 by 2 into d2 square into 1 by LF. Ts I'm putting in denominator, so it will be LF. Can anyone calculate the value of the d2? This d2. What will be the value of LF? L already given here 0.05 millihenry and F is 20 kilohertz. So 1 is equal to 1 by 2 into d2 square to 5 0.05 into 20. Can anyone calculate the value of d2 from here? See here V naught I have missed. V naught also it will be here. V naught. It will be V naught. Can anyone calculate value of d2 from here? This equation.
So 37.5 V naught, sir.
See, it will be d2 is equal to, I'm going to write d2 is equal to, here see 2, directly we can write under root 2 LF divided by V naught. Okay, from this equation 2 LF divided by V naught. So this value I'm going to calculate 2 into L how much 0.05 into 20 divided by 2 into 0.05 into 20 divided by V naught. V naught how much?
75, sir.
V naught is
Ah,
10.
10. Okay.
So it will be divided by 10. So I am getting at 0.44 something. 0.44.
Okay, sir.
Is it clear?
I put V naught equal to 75 volts, sir. Previous
No, no.
problem.
V
Sorry,
naught.
sir.
Okay, V naught is how much here? 10 only, na?
Sir, 10.
So 2 into 0.05 into 20. So 2. This is value is coming as 2. So it will be under root 2 by 10. Okay, under root 0.2. Which is equal to 0.44 something. So we have calculated the value of d2. Now we have to calculate the actual what is asking the question charge on time. This is not the switch on time. This is the off time. D2 is the off, like total off time will be this much. Okay, total off time will be this much. But for this much duration, inductor is charging. So this is the actual duty of the switch. Okay. So how we can calculate the value of the D1? So I'm going to write the volt second balance across inductor voltage. So VL during D1 TS time. D1 TS time, what will the value of VL? VL will be VS. And during D2 TS. So D2 TS means this is conducting in this way and this path is closed. Okay, till D2. After D2, this current will be 0. Here current will be 0 after D2. So it will be minus V naught for D2 time period. It will be minus V naught. So it will be minus V naught. Now we can apply volt second balance here. So D1 Vs minus D2 V naught. This should be equal to 0. So V naught divided by Vs should be equal to D1 by D2. So from here we can calculate the duty of the switch. So V naught how much? 10. Second. 10 divided by 15. 10 divided by 15 into D2. This will be the value of D1. So D1 will be 10 by 15 into under root 0.2. Can anyone calculate this value?
0.293, sir.
Okay. So it will be 0.293. Approx it will be 0.3. Okay. So this will be the actual duty of the switch. 0.3 will be the actual duty. D1. Anyone have doubt?
No, sir.
Okay. So in option 0.4 also will be given. Okay, one option will be 0.4, but we have to click 0.3. Okay, so I'm moving to the next question. If no doubt will be there. That is also discontinuous conduction based question only. Okay. So this question already asked in gate. Like previously one time asked like very early. After that next time this question repeated in gate
Sir,
2018.
sir, I have one doubt, sir.
Okay.
Sir, in previous question, charging time it takes 0.4 seconds, sir. 0.39 means,
This will be 0.39.
yes, sir.
Not 0.39. This will be 0.3.
Okay. And
And
D2 takes 0.2 seconds, sir.
due to how much we have calculated?
0.44. 0.44 seconds.
0.44.
For charging, it takes less time and discharging it takes more time, no, sir.
1 second. Maybe due to some circuit condition. See, it can discharge fast also based on resistance and all. Okay.
Sir, in this we include D2 and D3 equal, sir.
See,
That
see. Now I'm telling. If like some condition will be there, like charging time will be up to 0. Let's say we are saying 0.6 duty. So 0.6 it will go and it will discharge in 0.3 only. Okay. Discharging will depends on the load. Okay, it can discharge fast also. See,
okay, sir.
that will depends on load, like how much we are loading that resistance, load resistance. The 10 ohm is here. If that value is high, it will discharge very fast. See, this circuit, this it is discharging very fast, charging but discharging very fast due to this load. Otherwise, if it will not discharge very fast, then it will go up to here. Here means it will be 0.3 and 0.7. That will be the boundary condition. If it will discharge for after 0.7, okay, 0.7. So that we can say that this is boundary condition. But why it is discharging fast? Because high resistive load. Okay, is it
Okay,
clear?
sir.
Okay,
Yes, sir.
okay. So this is the next question. So here two voltage source are connected to, like from this point to ground. This is V1 and this point to ground. This is V2. So in question is asking the what will be the power transfer from V1 to V2 and duty of the switch is given. So we can like write this is the boost converter, this charging and discharging. So what is the equation for boost converter? VO is equal to 1 divided by 1 minus D into Vs. So it should be 1 divided by 1 minus 0.5 into 100. How much we are getting? 200. So if basic formula is not giving the correct result, it means that the converter is working in the discontinuous conduction. Is it clear? See, if this formula will not work. If this will work means the like the converter is working in the continuous conduction mode. This derived from continuous conduction. Okay. If this is not giving the correct result means we can conclude that the converter is working in the discontinuous conduction mode. Is it clear?
Yes, sir.
Okay. So now we have to calculate the power transfer from V1 to V2. So you can calculate either power from this side or from this side. So in middle no losses are there. So if you will calculate this power also, sending in power and receiving in power, both will be same. Okay. So here DC voltage we already know. So what I am going to calculate, what will be the average current here? Average current here. So waveform will be like this. Waveform will be like this. This is charging time. dTs, d1 Ts, and this is d2 Ts. Okay, this will be Ts. So this is charging means this switch will be on. When this switch will be off, what will the current? Current will flow through this one. So this is the second part. So current will be like this. D2 Ts, this will be Ts. So if we can calculate the average of this current, that same thing will multiply with this V2, that will be the average power. Is it clear to all? Is it clear?
Yes, sir.
Okay. So for this one, first we have to calculate the value of D2. What will be the value of D2? So D1 already given. Okay, this is D1. On time of the switch already given. We have to calculate the D2 value. So how we can calculate? D1, like let's say average volt second balance we can write. So VL during on time. Okay. On time, what will be the VL? This is plus minus VL. So switch will be on, VL will be same as VS. Okay. VL or D1. D1 TS, what will the value of VL? It will be VS. And D2 TS, so D2 TS it will be, VL will be, when the switch is off, so VL is V1 minus V2 means VS minus V0. Okay. So value will be Vs minus V0. Here we can apply volt second balance. So D1 into Vs plus D2 into Vs minus V0. This should be equal to 0. So here we can write as D1 plus D2 into Vs equal to D2 V0. So V0 by Vs should be equal to how much? D1 plus D2 by D2. So from here we can calculate the D2 value. Can anyone tell what will the value for D2? The V1 is 100 and Vs is 100, V0 is 300. So here 300 by 100, this should be equal to 1 plus D1 by D2. Okay. And D1 by D2 will be 3 minus 2, 1, and 3 minus 1, 2. So D2 will be D1 by 2. Is it clear to all?
0.25, sir.
Okay, what is the value of D1? D1 already given 0.5. Okay, so D2 will be 0.25. Okay, what will be the value of delta IL here? This delta IL. So this we can calculate from on duration. On duration, what is the value of inductor? VL is equal to Vs. So delta IL will be D1 into Vs by LF. This equation is clear to all? What will the delta IL? This peak value. Same, we can apply y2 minus y1 divided by x2 minus x1. So x2 minus x1 d1 ts. So delta L we can write as d1 vs divided by LF. Is it clear?
Yes, sir. Similarly,
Okay.
we can use D2 also, no, sir.
D2
One
also
minute.
D2 also we can use, but I'm using D1. D2 also we can use. That also will work.
Okay. Okay, sir.
See D2, if we are using means again this voltage minus this voltage we have to take. That way also we can solve. So, but I'm taking D1 here. Okay. So the waveform will be like this. If you want, I will calculate with both way. Okay. Now this is D2. D2 TS. And what is the this length? D1 Vs by LF. Okay. This is like I naught. So average of this value will be average output current. So what will be I average be equal to 1 by 2 into first 1 by Ts into area, 1 by Ts, area will be 1 by 2 into D2 Ts into D1 Vs by L into F. So this will be the average value of the current. Ts will cancel. So it will be d1 d2 Vs by 2LF I average. So what will be the average output power? So average output power will be V naught average into I average. So that will be, we can write direct d1 d2 Vs V naught by 2LF. So directly you can memorize this formula also. What will the power transfer between these 2 points? That will be d1 d2 Vs V naught divided by 2LF. Is it clear?
Yes, sir.
Okay, so we can calculate from here. So what is d1? d1 is 0.5. 0.5 into d2 is 0.25 into Vs 100 into 300 divided by 2 into L, how much? 100 micro into frequency 20k. 100 into 10 to the power minus 6 into 20 into 10 to the power 3. Can anyone calculate this value? I'm also calculating.
937.5 watts, sir.
Okay, so this will be 937.
37.5.
One similar question is given in GATE 2018, so you can go and solve that question also after this class. It will be same only. Just data they have changed. So you at GATE they are repeating the question also. This question they have asked, I think, long like before 2006 or 7. Again they have repeated this question in 2018. Same question, just this VS and V naught data is different. Okay. Should I move to the next question?
Yes, sir.
Okay. Okay. One second. So for this question, I will give you some time, like 1 or 2 minutes. You can think. Easy question only. How we can calculate conduction loss? This device drop is given as 0.5 volt. Okay, for this device, and the converter is working at boundary condition, at boundary of the continuous and discontinuous. So in this case, we have to calculate the conduction loss in the switch. This switch we have to calculate what will be the conduction loss. Everyone got the last question, all discontinuous conduction, whatever I have explained till now. Is it clear to all? Okay.
So for this, we have to use V into I, sir.
V into, see, this is drop across the switch. So drop will be plus minus. This will be plus, this will be minus. So this is VD, device drop. And some current will flow through this device. Ready? So what is the average power? Average power will be 1 by T into integral Vi dt, 0 to T. This will be the average power. Okay. So if one value will be constant, so here what is constant? Vd is constant. Okay. So Vd I am taking common. So Vd will be common into 1 by T integral of I into dt. So this will be the average value of the current. Okay. So what we need, we have to calculate the average value of the current here. That average value of the current, if we multiply with Vd, then we can get the drop of switch average power. Is it clear?
Yes, sir.
So if two quantities are given, like voltage or current, and one of them is constant, we will take the average of the another signal. So here this device drop is constant. So what will be the other value? Average of the current through the switch. So we have to calculate the average of the current through the switch. That we will multiply with the device drop. Then we will get the conduction loss through the switch. Okay. And if resistance will be given, in other case, if resistance of the switch will be given, then what we will calculate? IRMS. Okay, so in that case, average power drop will be IRMS square into R switch. So this you have to remember. Okay. See, for R will be there, voltage drop will also be variable across the switch through the R, and current will also be variable. So both quantities are variable means we have to consider the RMS value. Is it clear?
Sir, sir, in some cases, IRMS square into R switch plus V switch plus ID, sir.
Okay.
That also have.
See, let's say both things are given. This is resistance of the switch, and this is the device drop of the switch, and some current is flowing through this. Okay, this is R switch, and device drop is VD. So what will be the average power? Average power will be I RMS square into R plus I average into VD. This will be the total loss through the switch. Okay. One loss will be in the internal resistance of the switch. Another loss is due to the on-state drop of the device. So total average loss will be this one. Is it clear? And
Yes,
why
sir. Yes, sir.
average will be considered for the drop since this quantity is constant. Okay. Across resistance, if we are seeing, so voltage will be a function of current, input current. So across the resistance, voltage also is variable and current also variable. Okay. So in this case, we have to consider the RMS value. And here if we are seeing this voltage is constant and current is variable. So this we are taking outside. Already I have explained here how it is. V I am taking outside here. So 1 by T into integral IDT, this will be the average of the current. So what we can say that the average power due to this drop will be I average into VD. Is it clear?
Yes, sir. Clear, sir.
Okay, okay. So I am also going to solve this question. How? See, if device drop will be given as more, then we have to consider this also. Now here also I am going to consider this, but it will be negligible only. So current waveform will be like this. For boundary of continuous and discontinuous conduction, what will be the current waveform? This is total TS, and this is on time DTS, and off time will be 1 minus DTS. Okay. So during on condition, what will be, which part will come? Switch will be on, this first part will only come, another second part will flow through this one. So we have to calculate the average of this waveform, first waveform, dts, and this total is ts. Okay. So duty is, we can calculate from this data. Can anyone calculate what will be the duty? This is buck boost converter. See, V naught divided by Vs, so d divided by 1 minus d. Okay. So 1 by 4 is equal to 1 by d minus 1. D is equal to 1 by 1.25. How much this will be?
0.8.
0.8. So duty we already got. So with this duty we can, this peak also how much? dVs divided by LF. Okay. So you see the current waveform dTs, and the peak will be dVs by LF. So see here I have written Vs, but if drop will be more, let's say this drop is more, 0.5 is not there, some other value is there. So during on condition, what we can write, what is the inductor voltage if the switch will be on? So inductor voltage will be VL will be Vs minus Vd. We have to subtract the device drop. If this switch will be on, so across inductor, the VL will be Vs minus V device drop. So it will be Vs how much? 100. 100 minus 0.5. 100 minus 0.5. This is the VL value during on condition. Okay. So in place of this one, this Vs will be D into Vs minus Vd divided by LF. It clear?
Yes, sir.
So this value we can calculate. So what will the value of delta IL from here? Delta IL is equal to D how much? 0.8. 0.8 into 100 minus 0.5 how much? 99.5 divided by LF. L how much? 100 micro, I think. 100 micro, frequency 10 kilohertz. 100 micro into 10k. So this 3 and 4 and 2 6. So it will be, how much it will be? Delta IL 0.8 into 99.5. 0.8 into 99.5.
79.6 volts, sir.
So delta IL is 79.6 amp. Okay. So we can calculate the value. I average is equal to 1 by T into area. So 1 by 2 into DTS into 79.6. So TS will cancel. Okay. So 1 by 2 into 0.8 into 79.6. This will be the average value of the current. So 0.4 into 79.6. How much?
31.84, sir.
31.84. So we got the average value of the current. I average we got. I average is equal to I switch average. I switch average to 31.84. So if this value will multiply with 0.5, that will be the power. P average will be 31.84 into 0.5. How much?
Square, sir. 31.81 square.
No, into 0.5. 31. No, not a square, because see, here device drop is given. Here, this only we have to see. Here in question resistance is not given. Okay.
Okay, sir.
So here we have to see, like, use the average value. Average value already we have calculated. So what will the P? P average will be I average into VD. Okay. So 31.84 into 0.5. It will be 15.92.
Yes, sir.
50.92 watt. So we have to be careful. When resistance will be given, this point you have to remember this, like repeatedly gate is asking this kind of concept. So if resistance is given, we have to take the RMS value, IRMS square into resistance of the switch. Okay. If device drop is given, what will be the loss through the switch? I average into VD. If both will be given, you have to sum these two, IRMS square into R plus I average into V drop. Is it clear?
Yes, sir. So for this question, we don't need to find discontinuous case, sir.
See, I'm going to the question. See here already given in the question, like working as a boundary condition. Okay. If this thing will be mentioned like working at a boundary condition, a question only if it will be written is working as a inductor current is always like positive. Like some statement will be given. Inductor current is always continuous or always greater than 0. It means we can conclude that the converter is working in continuous conduction. If nothing will be given, then we will check the condition for the continuous or discontinuous. Okay. That too, if 2 marks question will be given, then only we should think of this one. For 1 marks they will not give. Okay. 2 mark question will be there, fill in the blanks type question will be there. Then you have to first check this condition. Just one line equation you have to check, like 12 by RT. 12 by RT should be greater than 1 minus D square. This is for buck boost converter. For other converter also these derivations are there, that I will explain in the next class. Okay. This formula will be like critical. This K will be same for all converters. This will be different. Critical value will be different. So critical value for the this buck boost converter is 1 minus D square. This we can check. Is it clear?
Yes, sir. Clear, sir.
Okay. So last question I am going to discuss. Okay. This question. So here we have to check first the converter is working in continuous or discontinuous. You can check, already I have given the formula. Can anyone calculate whether this is continuous or discontinuous? How we can check? This is also buck boost. What is the value of 12 by RT? Two into 120 micro. We can write 12F by RT. So T will be into F how much? 25K divided by R. How much it will be? Two into 120 into 10 to the power minus 6 into 25 into 10 to the power 3 divided by R how much? 4. How much is value? This is 1.5. Everyone getting same value?
1.5 nanofarad.
Not nano. See this. How nano you are getting? This is micro and this is kilo. 1.5 constant it is coming.
Okay, okay, sir.
This K value, this value is 1.5. So this, if we'll check 1 minus d square, duty is how much? 0.25. So 1 minus 0.25 square, how much?
Zero 0.562.
So we can see that this value 1.5 is greater than 1 minus 0.25 square. So what we can calculate this? This is working in continuous conduction mode. Is it clear?
Yes, sir. Yes, sir.
So now we can, how we can calculate the RMS value of the switch current? This is the switch. Okay. So first I am going to calculate the output current. What will be the magnitude of the output current? It will be V naught by R. So V naught how much? Can anyone calculate V naught? V naught is equal to D by 1 minus D Vs.
4 volts,
How much you are getting?
4 volts, 4.
4 only. 0.25 divided by 0.75 into 12. Okay, 4 volt. So
4,
this
sir, 4.
4 volt final. 4 volt is correct. See, this will be 1 by 3. 1 by 3, 4. So what will the current? Current will be 1 ampere.
1 ampere.
It clear? So this is the load current. What will be the inductor average current? Can anyone tell? That
I
formula.
naught by 1 minus D. I naught by 1 minus D.
So it will be 1 divided by 1 minus 0.25. How much will be this value?
1.33 amps.
How much?
1.33 amps.
Okay. So this will be 1.33, means 4 by 3. It will be 4 by 3, around 1.33. So this is the average value of this inductor current. Okay. We can calculate delta IL also. So how we can calculate? Inductor average we got. Average we got. This is the
Delta here.
1
Vs by
point
L into D into T.
dVs by LF. This will be the delta IL. Okay. So already we have calculated the average value. I'm telling the steps here. You can calculate by your own. We'll share the PDF also in the group. So see, this is on time. This is on time from here to here. So here this delta IL at 1.33 some value will be added, delta IL by 2, and here also some value will be subtracted, minus delta IL by 2. So IL minimum and IL maximum. This will be the total time period. This is D1 TS and DTS. This is DTS, this is 1 minus TS. So it is just RMS value of the switch current. The switch current waveform will be like this one. It will be like this one, trapezoidal. Like this one it will be. This is IL minimum. This is IL maximum. Okay. This is DTS. So already a formula I have given. All of you have that short formula. How to calculate the RMS value.
Yes, sir.
Okay. So see, if let's say if resistance will be given for this switch, let's say R is equal to 0.01 ohm. Okay. So what will be the power loss through the switch? We have to calculate RMS of this current. So IRMS whole square into R switch. That will be the average power of that switch. Okay. So see this, sometimes if ripple will be negligible, in that case we can use as like directly, like we can assume this as a square wave. No need to go by this formula. Let's say ripple is very less. In that case, no need to go by this one. If ripple will be high, then only we should go by this formula. Okay. You are calculating by this formula also, then answer will be same. And then in that case, we can approximate like a square. Like let's say this is the inductor current, okay, average current. And these ripples are like this one, very small, charging and very small discharging. Okay. So in that case, we can assume that as a constant also. But if you are using this formula, that will be 100% accurate answer. After some 3 decimal, 4 decimal also, it will give the accurate value. Is it clear? Okay. Okay, so any doubt will be there, you can ask, otherwise we can close the session and we'll meet in the next session. Is it clear?
Clear, sir.
Okay, so I'll come on the next Monday